Okay, hi everyone. So today's will be our first lesson for the third topic, which is trigonometry. So this topic is actually quite a short one as well, and we'll complete this within this week also. So the content that we are going to learn, right, is basically the build on for the content that you have learned previously in Pure Max 1. So please make sure that you are familiar and maybe you can take a quick revision for what you have learned previously in Pure Max 1. Okay, so for today's learning outcome, we are going to cover two important things. So the first one is we will learn three trigonometry functions like the reciprocal one, which is the secant function, the cosecant function, and the cotangent function. Okay, so the same thing now we'll learn how to draw the graph and then how to use the properties, how to solve the equation and so on. Then after that, the second learning outcome is how do we actually make a further identities from the previously we have learned for the sine square theta plus cos square theta will be equals to 1, right? So today as we learn the secant, cosecant and cotangent function, so we are going to put these three functions to be used in the basic identities as well. So the same thing, you need to know how to solve equation, how to substitute, how to do some proving and so on. Okay, so these two are the main learning outcome for today's lesson. So it's the same thing like how we do logarithm. So the first lesson will be a quite an easy one because it's just like some recap and some introduction for you. Then after that you will be learning like much more new thing in the second and the third lesson. Okay, so let us go into the introduction. Okay, so in Pure Max 1, we already know what is that mean by sine, cosine, and tangent, right? So for this lesson, we are learning the other three, which is cosecant, secant, and cotangent. Okay, so the first one here is cosecant. So actually, they are the reciprocal for the trigonometry ratio that we have learned previously. So for cosecant theta is basically mean 1 over sine theta. Okay, for secant theta is basically 1 over cos theta. And for cotangent theta is 1 over tangent theta. So what is an easier way to remember this? You can just remember that you always look at the third alphabet. So you can see S, so that's why sine, second C, so that's why cos, cotangent T, so that's why tangent. So this is some tips that can help you to remember these three ratio. So please bear in mind that when we say reciprocal, they are different from what we have learned previously, which is the inverse. Yeah, so please make sure that they are different thing. So when we say inverse, meaning that we say that if y equals to sine theta, then sorry, let me use x, sine x, then x will be equals to inverse sine y, correct? But when we say reciprocal, it's totally new function, which is like 1 over sine, which is non-related at all with what we have learned previously for the inverse one. So make sure that you don't confuse yourself, okay? So since previously we have an identity that tells us that tangent theta will be equals to sine theta over cos theta, right? So since cotangent is the reciprocal or the inverse, sorry, not the inverse, it's like the reverse for tangent. So that's why we will say that cotangent will be equals to cos theta over sine theta. So this is like one of the very helpful identity that can help you to solve the equation later. Okay, so let's try to look at the triangle here. So these are the things that we have went through together also when we learn trigonometry in Pure Max 1. So we just try to put them in, then after that we are going to use this to help us to prove the basic identities. Okay, so sine theta, so we know that OH, correct? Sorry, OH. So yeah, your SOHCAHTOA. So sine will be equals to y over r. So your cos AH, right? So x over r. I'm not going to repeat this again. This is the unit circle thing that you have known previously. So tangent will be OA. So that's why y over x. So since cosecant is 1 over sine theta, right? So that's why it means that it will be the reverse for the sine theta here. So it will become r over y. Okay, so for second is 1 over cos theta. Okay, so it will be the reverse for the cos here, which is r over x. So cotangent is 1 over tangent theta. So that's why it will become x over y. Okay, so it's the same thing if let's say like in a normal triangle which you have a normal triangle which we didn't use the x, y, and r, and we use like o, a, h. So it's the same thing lah. So if we say that sine is s or h, right? So when we say for cosec, then it will be your h over o, something like that. Okay, so it's the same, but we are just going to use this form, and later we are going to look at the basic identities part. Okay, so for the next part, same thing. So as we learn trigonometry function, and you need to know how to draw the graph. So we'll be looking at doing some recap, like the revision for what you have learned previously in Pure Max 1. Then after that, we move on to the cosecant and the second and so on. Okay, so the first one, so I think you can remember this. So how to draw a sine graph. So a sine graph would be something like this. So you'll go from 0 to 1, and then back to 0, and then go to -1, then go back to 0, right? So this is how you draw a normal sine graph. Sorry, it's very hard for me to control when I use my pad here. So yeah, just try to draw a nice one in your handout. Okay, so this is a sine graph, which you have an amplitude of 1 here. Okay, then after that, when we look at cosecant, so how are we going to draw that? So you know that cosecant is 1 over sine, right? Okay, so you can imagine here, what happened here is, let's say, we try to write down the important points so it will be easier for you maybe. Okay, so when we say that theta is equals to 0, then our sine theta here, let's put y. So our y here, sine theta, will be equals to 0 as well, right? So when we have theta equals to 90, our sine theta is 1, correct? So when we have theta equals to 180, the sine theta will be equals to 0. Then when we have theta equals to 270, then you have sine theta equals to -1. Theta equals to 360, and we have sine theta equals to 0. Okay, so now you can try to imagine, since you want to draw a cosecant graph, right, is 1 over sine. So meaning that what happened here is at the point where theta equals to 0, and 1 over sine theta will become 1 over 0. So when you have 1 over 0, what does that mean? It means that it's like an undefined answer, correct? So it's the same thing you see when theta is 180, the sine theta gives you 0, which is 1 over 0 for cosecant also. So you can imagine for theta equals to 0 and the theta equals to 180 here, is going to be a infinite answer because 1 over 0 is not defined. And then let us try to see 90. So for the point 90, you have sine theta. So meaning that even you do 1 over sine theta, it's going to be 1 over 1, correct? So we now know that for the point 90 here is going to be 1. I hope that you understand what I'm talking. So theta equals to 90, meaning 1 over sine theta will be equals to 1 over 1, right? Then after that you get 1. But for theta equals to 0 and 180, you are getting 1 over 0. So that's why it's going to be an asymptote here, which you have a line, have a limit there, where your graph will never reach the line. So you will have a graph that looks like this. Okay, so it's getting nearer and nearer, but it will never touch the line. So the same thing, let's try to see when we have 270. So theta equals to 270, and when we draw 1 over sine theta, and what you will get? You will get 1 over negative 1, correct? So which gives you negative 1, so which is like here. Okay, but the same thing for 360 is 0. So 1 over 0, you are getting an undefined answer also. So you have another curve like this. Okay, so please make sure that at the end of this graph, so this is the asymptote, so you are not going to actually reach the line here. Okay, so it's getting nearer and nearer, but it will never touch it. Alright, so that's the idea. Okay, so let us try to move to the second one, which we look at the cosine. Okay, so we know that for cosine graph is look like this, from 1 to 0 to negative 1 to 0 and go back to 1, right? So your graph will look something like this. Yeah, this is not all right, yeah, so this is your cosine graph. Okay, so maybe let us try to do the same thing like how we find out for the sine graph. Okay, so you can see that for the point theta equals to 0 and the point 360, cos theta is going to give you 1, correct, at these 2 points. So for theta equals to 90 and 270, you will get a value cos theta equals to 0, correct? This point and this point. So when theta equals to 180, you have cos theta equals to negative 1. So let us try to do the same thing. So let's start with 0 and 360 first. So for the part where it's 0, you get cos theta equals to 1. So second is 1 over cos, right? So that's why you have 1 over 1. So you know that it's at 1 here. So same thing to 370. So 360. So it's going to be 1 over 1 as well. So that's why 1 here. Okay. So let us try to see the second one. So you can see 90 and 270. The cos theta is 0, which means it will give you 1 over 0, which is undefined here. So that's why you can see there are two asymptotes at 90 and 260. So you are not going to reach this line at all. So we know that the graph will look something like this. Okay? And then after that, the same thing for here. All right. And then for this part, how are you going to draw that? So same thing, you know that it's not going to reach here and here, right? So that's why let's try to draw the 100. So for 180, then you have negative 1. So 180, negative 1. So it's somewhere here. Okay? So this will be your graph for second. Okay, so you can just try to imagine if let's say, okay, so maybe I don't know whether you have the idea like why I'm not drawing like the tangent graph that looks like this and so on. Yeah, so you can try to imagine that for this part, right, is basically the part for here. So you can imagine I have negative 1 over 1, which give me this point, right? So as all this number approaching to 1, so actually all the number that approaching to 100 to 90 is actually a number that is like nearer and nearer to 0. So if we have something that 1 over the number that is getting smaller and smaller, it will give you a bigger and bigger number. You get what I mean? So meaning when I compare like 1 over, okay, let's say this point is negative 0.2, then 1 over negative 0.5, then 1 over negative 0.8. So when we have all this number, which when you see all the denominator part become like greater and greater in terms of negative, but then when you try to change it into what is that called, change try to get the reciprocal of it, you actually get a number that is bigger and bigger. So like this one will give you like negative 5 and negative 2, then negative like 1.25 maybe, so something like this. So when you try to do this, then you can see that, so as this increase, so this one should be increased, because when you see the number is getting like smaller and smaller, so it should be like, it's not like smaller and smaller, I mean smaller and smaller in terms of like the negativity, or in numbers that we say that the number getting bigger lah, so that's why you have a curve like this. So when it reach this point, then it go from this side to this side, right? So from here to here, so that's why you have a part that is like decreasing now. Okay, so that's the idea of it. Okay, so the same thing, let's try to look at the tangent one. Okay, so we know that for a normal tangent graph, you already have an asymptote here. So it's like this. Oops. Okay, so the same thing, maybe you want to draw it nicer a bit in your handout. Okay, so this is the original tangent graph. So for cotangent, it's going to be 1 over tangent theta, right? Okay, so now how are we going to draw this? So this is the same thing as well, but then it will be a little bit much more confusing because you didn't learn the idea of limit previously. So that's why it will be a bit difficult for you to understand, but yeah, you can try to. Okay, so the idea of, you can see the point, you will have theta equals to 0, 180 and 360 will give you tangent theta equals to 0, right? So that's why you can see the new asymptote here, the 180 and the 360. So because 1 over 0 is going to give you an undefined answer. Okay, then after that, let's try to see the part where you have asymptote. So for here, you have theta equals to 90 and 270 will give you tangent theta equals to infinity. So can you try to imagine when you have a number of infinity and when you do 1 over infinity, what do you get? So you can imagine 1 over infinity, infinity is, it can be like a very large number or very small number. So when you have something that, okay, let us try to look at the idea for like a very big number, so that would be easier for you. So if I increase from 1 over 10, 1 over 100, 1 over 1000, 1 over 10,000 and so on, you will be getting a number that is smaller and smaller, and this number is going to be approaching to 0. I hope that you can recall a bit from the Pure Maths 1 when we learned about the integration, which I explained this before when we talk about when you have a limit, the number. So it's like the limit when you have a number that is approaching to infinity. So your 1 over n will be approaching to 0. So that's the idea. So that's why for 90 and 270 is going to be 0, 0. Because when you have a number that is infinity and you do reciprocal of it, then you will be getting 0. So that's why your asymptote is here. So you can try to imagine using the same thing here. So this number is getting bigger and bigger in tangent. So when we do reciprocal, when your denominator become bigger and bigger, meaning that they will give you a smaller and smaller number in reciprocal. So that's why your answer will be like this. Okay, so same thing, go for here. Because they are the same period, right? So you can draw the exactly same thing. Okay, so yeah, I just repeat again. So I hope you can understand the idea is we find out what is the asymptote. Then after that, you look at this is like an increasing function. So when your tangent theta get increase and increase, but this is reciprocal. When you have your denominator bigger and bigger, you should have your reciprocal smaller and smaller. So it's the same thing like for your cos as well. So you can see that this one getting smaller and smaller. So as your reciprocal getting smaller and smaller, then your as your denominator getting smaller and smaller, your reciprocal will become bigger and bigger. So the same thing, if this one getting lesser and lesser and go up again, then this one will become go up, then after that go down. It's like the reverse for, because when we do reciprocal, we know that when your denominator increase, then the whole thing will increase. Yeah. So that's the idea of it. Yeah. So you can, but then I would say compared to your pure max one, the application of cosecant and secant in graph is not that popular, or the questions is not so popular compared to your sine graph, your cos graph, and tangent graph. Yeah, but it's just like knowledge for you, and you need to know like that is in your syllabus itself. Okay, so let's try to look at the next part. Oh yeah, for the graph part, I'm not going to repeat for the part that we have learned previously, which is the part that uh for the transformation of the graph. So you already know that if you have, so if let's say you have like cosecant uh cosecant x plus 1, so you know that you should be able to like move take vertical displacement of 1 units upwards like that. So if you have like secant x plus 90, then you should know that your whole graph should be moving to the left hand side then by 90 degree. So I'm just putting in the recap here. So you might want to like make a revision by yourself, because that's the thing that you already know, and I do not want to prolong the video here. Okay, so let's look at the next part, which we talk about basic identity. So we just do a quick recap on what we have learned previously. So you know that the first identity that we have learned in Pure Max 1 is sine square theta plus cos square theta equals to 1, right? So how is this basic identities come from? It actually comes from your Pythagoras theorem. So from just now, you can look at your notes first page. So we have the triangle, right? So this is your y, your x, and this is your r. So we can see that the a square plus b square equals to your hypotenuse. So that's why x square plus y square equals to r square. So how is this formula come from? This formula come from when we try to divide the whole thing by r square. So you will have x square over r square plus y square over r square equals to r square over r square. Then we have x over r square plus y over r square equals to 1, correct? So x over r is actually, sorry, this one I make it, yeah, but it's the same. X over r is cos, right? Then after that, y over r is sine, then equals to 1. So this is how we get to our first basic identity. So the same thing, let's try to derive the second one. So maybe let us try to divide by x squared first. Okay, so when we divide by x squared, then we'll have x squared divided by x squared plus y squared divided by x squared equals to r squared divided by x squared. So same thing, you get 1 y over x and then r over x. Okay, so 1 plus, so what do you can remember? Y over x gives you tangent. Okay, so r over x, so if it is difficult for you to remember, then you can remember x over r is what? So x over r is cos, correct? So what is the reciprocal for cos? Is secant. Okay, so this is how we get to our second basic identity, which is 1 plus tangent square theta equals to secant square theta. Okay, so same thing, look at the last one. So now we are going to divide everything by y squared. Okay, so x squared divided by y squared plus y squared divided by y squared equals to r squared divided by y squared. So you have x over y squared plus 1 equals to r over y squared. So x over y is the reciprocal of y over x, right? So it's going to be cotangent plus 1 equals to r over y is what? So y over r is sine. So r over y will be cosecant. Okay? So cosecant theta square. So we get our last identity here, cotangent square plus 1 equals to cosecant square theta. Okay, so these are the three basic identities that we need to know in trigonometry function. Okay, so when you look at your fourth page, it's like your recap of the drawing graph. So the formulas that we learned today will be given in your exam in this term. So meaning that they basically give you everything already. It's just that for the cotangent, you need to know is the inverse of your cos by this one. So this is the thing that you need to remember yourself. Then after that, also like cotangent is the reciprocal for tangent, then cosecant is the reciprocal for sine, then secant is the reciprocal for cos. Yeah, so those are the things you need to remember yourself. Okay, so now we'll be looking at 3 examples, then after that we'll end the lesson. Okay. Okay, so let's try to look at number one. So this is a very short one. I just want to introduce you the idea for cosecant. Okay, so the same thing. So let's try to write them in a reciprocal form. So cosecant for 240 degree will be equals to, so try to change it into the reciprocal form. So you have 1 over sine 240. Okay, then after that try to use the knowledge that you have learned previously. Okay, so 240 will give you maybe up to here. So what is the reference angle? So it will be 240 minus 180, right? Then after that 1 2 3, this is the third quadrant. So A S T C. So at this point it will give you a negative. So 1 over negative sine 60. Okay, I hope you still remember. The first step, find the reference angle, which is the angle between the line, the angle that you want to find, and the horizontal axis. Then after that, you know that this is 60. Then after that, find out your quadrant and then identify the ASGC. So at third quadrant, only tangent give you positive. So that's why sine here is going to be a negative. So now you have this special angle already. So what is sine 60? So exact value, sine 60 will give you square root 3 over 2. Then you rewrite them again. So you give you negative 2 over square root 3. So this is irrational. So that's why for the bottom part, we need to do our the rationalize of your cert here. So you will get negative, then after that 2 cert 3 divide by 3. Okay, so this will be your last answer. So if you want to check it with your calculator, I mean in your working part, it shouldn't show you that you should always use your calculator, but you can always use the calculator to check your answer. So when you check your calculator, please make sure that when you want to press cosecant, right, it's not equals to shift sign. So please make sure that this and this, they are totally different thing. So in your calculator, there is no button that can straight away give you cosecant, secant, or cotangent. So what do you need to press is you need to change it into sine first, then only you can press. So 1 over, so sine 240. So sine 240. Okay, so equal to, then you can check. You get the exactly same answer. So you know that you are correct. Okay, so let's try to go to second questions. Okay, so number two, solve the following equation. So the equation is actually quite an easy one also. So it's just for you to get familiar with the function. So second theta gives you 2. So same thing, the first thing that you need to do is change it in sine cos tangent first. So this is second, right? So it's the reciprocal for cosine. Okay, so gives you 2. So meaning that cos theta is 1 over 2. So same thing, use your calculator to help you to get, or if you can remember the exact value, then that would be good. So your reference angle will be 60. So it's the same thing that what you need to do, the circle thing. Okay, so 60, so you know that ASTC, so that's why it's going to be the first quadrant and the fourth quadrant. Okay, so it's like 1 and the other one up to here. So that's why your theta will be equals to 60 and the other one is 360 minus 60, which your last answer is 60 and 300. Okay, then after you have get the answer, then you can always use your calculator to check as well. So it's the same thing, but now because you cannot press second in your calculator, right, so you need to press the whole thing. So like 1 over cos 60, then you can check whether, oops, sorry, whether it gives you 2 or not. Okay, so 2, correct. Then you press, put in the other one, 300. Yeah, so it gives you 2. So you know that your answer is correct. Okay, so let's go to B. So the same thing, but now you have a square. So what we can try to do is we try to write it in the form of square outside first. So cotangent square theta equals to 3. So it will be cotangent theta square equals to 3. So now you can move it up. So you have positive, negative, square root 3. Okay, so after you get this, then the same thing that you need to do. So cotangent is 1 over tangent, right? So meaning that what do you need to do? So tangent will become positive and negative 1 over square root 3. Okay, so same thing by using your calculator to get what is your reference angle, and you will be getting 30. All right, so after that, same thing lah. So now you have positive and negative, right? So you know that all 4 quadrants can be accepted here. So meaning that you should have 4 answer here, which is 30. Then the other one is 180 minus 30, 180 plus 30, and the last one is 360 minus 30. Okay, which your answer is 30, 150, 210, and 330. Okay, so the same thing, you can just use your calculator. So you can't press that, then it means that you will need to, in bracket, 1 over tangent. Let us try out maybe 150. Okay, so you put the whole thing already, then after that you square your whole equation. So you see, it gives you 3. So it's correct. So you can try out the other one. So all will give you the exact same answer also. Okay, so let's try to go to number C. Okay, so C, 11 plus 3 cosecant 2 theta equals to 1. So when you look at this question and you see the 2 theta here, then meaning that you should change your range first. So this question want your answer to be in between 0 up to 360, right? So that's why if you are solving for 2 theta, meaning that you need to accept the range up to 720. Okay, then now you can continue. So 11 plus 3 cosecant 2 theta equals to 1. So let us try to simplify it and rearrange the whole equation. So we have 3 cosecant 2 theta equals to 11 over here, then you get negative 10. So cosecant is 1 over sine, right? Then you have negative 10 over 3. So since we want to solve for sine, so we need to change it opposite also. So that's why negative 3 over 10. Okay, so the next step, you can just use your calculator to continue it. So you will be getting a sine negative sine 17.45. Okay, so after you have this, then you can do the unit circle. So this is negative, so that's why it's going to be the third quadrant and the fourth quadrant. Okay, but don't forget, you should accept your value up to 720. So meaning that you need to have to round later. So your 2 theta will be equals to the first one, the third quadrant one, so 180 plus 17.45, and you have the next one, 360 minus 17.45, and you also have the third round, meaning you have 550 plus 17.45. Sorry, I should write over there. Okay, 540 plus 17.45. Then the last one is 720 minus 17.45. Okay, so you get all this value. Then after that, you can divide them all by 2. So we just write our answer in 3 significant figure here. So 18.8 degrees, 171.3, 278.8, and the last one, 351.3. Okay, so after you had get this, the same thing lah, like what I have said previously, so you can always use your calculator to check this as well. So we just randomly pick one maybe. Okay, so 11 plus 3, so cosecant, so it will be 1 over sine. So don't remember it's 2 times, okay? So maybe you just check out this one. So 2 times 171.3. Alright, and see whether it gives you a number that's very close to 1, because this is the number that you have rounded, so that's why you will have like some rounded issue here. So but make sure that you don't get a number that is like very far to 1 lah. Okay, so this is like the idea how you check it. Alright, okay, so let's move on to D. So secant square minus tangent x minus 3 equals to 0. So when you look at this question, you can see that you have 1 secant, then you have 1 tangent. So we know that it's the same thing like when we have a quadratic equation which you have x and y, then definitely you can't solve it because you have 2 variables. So that's why we need to change one of them into the other thing. Okay, so from just now the identity, so you do you still remember the second one? It will be equals to what? Yeah, so we have a identity that tells us that 1 plus tangent square x gives us secant square x. Okay, so now we can always change this part. So secant square x, we can change it to 1 plus tangent square x. So now we have a quadratic. Okay, so continue to simplify it. So tangent square x minus tangent x minus 2 gives us 0. So same thing, factorize it. So you'll be able to get tangent x minus 2 and tangent x plus 2. Sorry, plus 1. Okay, so you will have tangent x equals to 2 and tangent x equals to -1. So you will need to solve it separately. So from tangent x squared, x equals to 2, you can get tangent 63.4, is it? Sorry, let me just try it out. Okay, shift tangent 2. Okay, 0.43. Alright, then after that, same thing, x will be equals to, I think no need to draw, so you should be able to do that. So your first tangent, sorry, your first quadrant, then AST, your second, your third quadrant. So this one will give you 33.43 and the other one is 243.43. Okay, so let's move on to the next one. Same thing, so use your calculator. You should be able to get negative tangent 45. Okay, so now you can try to find it out. So same thing, this is negative. So it should be second quadrant and fourth quadrant. So second quadrant and your fourth quadrant, which is 360 minus 45. So the x here, you will be getting 135 and 315. Okay, so your last answer, just write put everything into one last statement. 243.43 and 215. Okay, but of course these two, if you want, you can try to change it to three significant figure lah. Okay, so the same thing, if you are using your calculator, you can use it to check as well. So second here, which is 1 over cos. Okay, so let us try out 315. So make sure that you square it because this is second square. Okay, so this is 1 over cos, meaning give you second, then after that square it, give you second square, then minus tangent 315 minus 3, so 0, yeah, which is correct. Okay, so you can try to check it out also for other value. It will give you the exact same answer as well, but maybe this one, because of rounding, so you might have a bit answer a bit different in the answer that you get. Okay, yeah, so this is a pretty small number as well, which is like very close to 0. Okay, so let's look at the last questions. Okay, so the last question is some proving questions. So yeah, so these are the three identities that we have learned just now. So we need to use it to prove our identities. Okay, so the first one, so let us always start with the left hand side maybe. Okay, so 2 tangent x over 1 plus tangent square x equals to 2x, 2 sine x cos x. So make sure that you don't copy the whole thing. So start with your left hand side, then you need to think of what is the method that you should take for you to reach the right hand side. Okay, so 2 tangent x, then 1 plus tangent square x. So you can see you left with sine x and cos x, so of course that you will need to change both of this. So since you have 1 plus tangent x give you second square, right? So we can straight away change this into second square x. So the 2, how about the 2 tangent here? So since we have sine cos, so we can always change it into sine x over cos x. Okay, so now we can try to expand it. So 2 sine x over cos x. So 1 over second square x. So can you try to, okay, it's okay. Let me try to do it step by step so you won't feel confused here. So 2 sine x cos x, right? So we know that for second x, is 1 over cos. So 1 over cos give you what? Give you again cos. Can you get the idea? So, okay, the idea is if secant x gives you 1 over cos x, that meaning cos x is 1 over secant x as well. So that's the idea of it, because this one you can try to exchange their places, right? So that's why 1 over secant square x is basically cos square x. Okay, so now we can continue. So cos x, cos square x, so you have 2 sine x, cos x. Okay, so proof. All right, so let's try to see the B. So same thing, let's try with the left hand side. Okay, so for this one, since it's tangent theta and cotangent theta, so that's why I think it will be easier for us to just expand it first. So you will have tangent square theta plus tangent theta cotangent theta 2, and then plus cotangent square theta. Okay, so now you can continue. So you need secant square and cosecant square. So now you can think of what is the way that you can change it already. So tangent square theta. So by using this, so you have secant square theta minus 1, because you want tangent square, right? So you should be moving negative 1 over here. So plus, so 2 tangent theta, and cotangent theta is 1 over tangent theta. So later you can try to like cancel them out. So plus, so how about cotangent square? So you can change it into, sorry, I don't have enough space. So cosecant square theta minus 1. Okay, so now you have secant square theta minus 1 plus, so here tangent theta and tangent theta, they cancel each other, so you're left with 2, and then plus cosecant square theta minus 1. So negative 1 plus 2, you get 1, 1 minus 1, you get 0. So that's why you get secant square theta plus cosecant square theta. So which is what you want here. So proof. Okay. Alright, so that's it for today's lesson. So please try to take this time to just finish your exercise and so on. So we'll be learning like more formula in the next 2 lessons. Alright, that's it. Thank you.